the actual services that you're continually running in the background, like your cron or your Apache or your MySQL service, is that you have what's called a contract, which is kind of a new abstraction in the operating system, where, for example, here we have a contract which has one process, which is for the cron service, and then it was created by the startd part of SMF. And so if something happened, if there was a hardware error or this contract became empty, if cron somehow exited, then the creator process gets notified that this contract is now empty. And then it knows, oh, I gotta look, see why that went away, and then if necessary, restart that service or flag it as down because of some sort of an error that occurred. And then, like we mentioned earlier, you can have either like a long-running continuous process like your web server, database server, or it could just be a transient service, which is the run once and then exit kind of type. In the manifest for the service, you declare the user and group credentials that you want the process to run over, any privileges, does it have any special privileges, or do you take away privileges? You can deny privileges of a process of like being able to enumerate the process list, so that you could only see processes that belong to the same user ID as you, or only processes that are in your same session. Like if you take away all those privileges, if I do a PS in my shell, I'll only see my shell and my PS. I won't see anything else from any other process, even if it's another process running as my user ID in another window. And so you can set up your working directory you want it to run out of, your environment variables for any configuration information, and then you can put your resource pool in there to tell it, that controls your resource limitations for like how much memory is it allowed to use, how many threads and processes can it have. You can delegate the administration of the services, so you can give a user a profile that allows them to administrate or manage part of a service. And so I've just got a little demo script here for that. Okay, so here for the cron service, it has this SMF manage cron authorization. And in this case, my user ID has the cron management profile, and here I'm just running as a standard user ID. So there's cron, there's the process ID of it right now. And then we restart cron. Didn't have to become root, didn't have to be a different user or anything, because my user ID was granted right here. The cron management profile has the Solaris SMF manage cron authorization. So as a user ID, like for example I do this on our web host, where I have my Apache user has the authorization to stop and restart the web server service. So if I need to restart Apache, I don't have to log in and become root. I can just run the service admin command as the regular Apache user. And then you can also delegate, like in this case, the action authorization means that I can stop and restart the service. There's other authorizations that would allow me to like change the properties of the service. Changing like any of the settings, what working directory does it run out of, what resource pools and limitations are applied to that service. So in this case, I can't make those changes. I'm just allowed to stop and start it. I can't say, suddenly give my my service, tons more RAM if the system administrator doesn't want me to. And part of what SMF ties in with is another feature called the fault manager. With that fault manager, you have a series of diagnosis engines, and they get information from different points in the operating system. Whether it's something like SMF reporting that a service has segfaulted and failed. Also, you can get hardware error reports from the different drivers in the operating system. And then as those error reports are fed to the fault management daemon, it runs these error reports through the diagnosis engine, and then decides that, oh, we're seeing a lot of ECC memory errors coming from this bank of RAM. You know, we need to retire that bank of RAM, so we're no longer going to be putting any processes in that memory address space. On the higher end Sun machines, they've got like ECC like on the data buses to the CPUs. So they can see if a CPU is starting to report memory errors like on its L2 cache. And then they can go, oh, this CPU is faulty, let's stop scheduling processes on there and just offline that CPU. So that CPU, you're now not going to run, you're not going to run any applications on it that might crash your application. You're also not going to run any kernel code that would panic the box. And then you can also, like when you have multipath disks, like with your big fiber channel arrays, when you have multipath and one of your fiber cards blows out, it'll fall over to using your alternate path if that's available. With ZFS, when the disk driver layer starts reporting errors from a disk, then it will activate a hot spare in your ZFS pool if you have a hot spare set up. And then finally, you can send out alerts, either like regular old syslog alerts or SNMP traps, like a management station, notifying that something's going wrong and there might be some admin intervention needed. All right, now this is always a big popular topic with ZFS. One thing ZFS does that's different from all of your standard file systems you may be used to dealing with is that you no longer deal with partitioning and slicing up your disks and having to set up where all your different file systems reside. You just take, like in this sample, this kind of graphic of mine here, say this is a storage pool with 16 disks in a mirrored configuration. So all of these disks then contribute their space to the general storage pool, and then out of that storage pool you just allocate whatever space you need for your different file systems. Or there's also a volume layer. With the volume you actually get like what looks like a regular disk block device, and so you can use that, for example, like with an Oracle database. A lot of times with Oracle you would point it at a block device for your actual storage. So with this you can create a ZFS volume, have Oracle use that ZFS volume as its disk, and then you get all the advantages of the pool of being able to expand your space, of having the compression, or also one of the new recent putbacks to the code, they added deduplication support. And so you get all the benefits of having ZFS under the hood with while still running your application on top of what it thinks is a regular disk, block disk device. And it makes your administration a lot easier. There's 2 commands for all of ZFS. There's the zpool command that you use for managing all of your actual disks and storage devices, and then the ZFS command that you use to create your file systems or block devices, set your properties on them, make snapshots. Out of the pool, it's structured into one or more of what they call VDEVs, a virtual dev. Like in this example here, each of these groups of 2 disks would be a mirror VDEV. And then your VDEVs can be a stripe, which don't use a stripe. If you ever trust your data, if you ever like your data, you want to ever keep your data, don't use a stripe. Because if something happens, if there's any corruption on a stripe, there's no redundancy and your data's gone. Then you can have a mirror, you can have a RAID Z, which is like a RAID 5, where you have single parity, and then RAID Z2 and RAID Z3 for double and triple parity if you're really paranoid. Also, with the reason that ZFS has these VDEVs attached to the pool is that you can always attach additional VDEVs later to that pool to expand your pool. It natively has NFS v4 ACLs, which are based off of NTFS style ACLs. So it's got the lot richer inheritance and a lot richer, finer grained control than the standard Unix user group and other permissions. You can create basically an infinite number of snapshots off of any of your data sets, whether it's a file system or a block device off of your pool. And then you can take a snapshot and clone that into being a new operating or a new writable file system. That actually comes in handy later on with the package management system, because for doing an upgrade, you take a snapshot of your root file system, you clone that to a new writable copy, apply all your patch updates onto that writable copy, and then reboot from that new file system. So if anything ever goes wrong, your original file system is still there, and you're not offline while you're doing your patching.
Ivan,
Yeah.
the NTFS, that's the Microsoft?
Yeah.
Standard?
NTFS has got a really well, see, if you've ever used any ACLs on any Unix-like system, a few years ago there was a POSIX draft standard for producing ACLs on Unix, but it never really got past the draft stage. So some places some operating systems adopted it, some operating systems took up some of the features but not everything. But in the meanwhile, the NTFS style ACLs have been around since Microsoft NTFS, and you can basically have a long list of all of your privileges. Let me get to where's the here you go. This is what an NTFS-like ACL looks like, where you have an explicit, here the owner is allowed to read, write, append, write attributes, execute the file, create attributes, create a new ACL, or change the ownership of this file.
Can you show us an example of the NFS ACL?
Well, this is the NFS version 4 adopted the NTFS style ACL layout.
All right.
And so the designers of ZFS just incorporated that right away, because the standard Unix, where you've just got the 8 bits of privilege for your, read, write, execute for user group and other, really doesn't give you a whole lot of room to expand and really define a really rich or complex access controls.
So NTFS actually, this Microsoft standard or whatever it is, actually has some value to it.
Yeah, that is definitely one useful thing.
It's surprising. Well, I shouldn't say surprising. That's new information to me. Thank you. Yeah. So NFS has kind of come into, V4 has more or less adopted the NTFS, the Microsoft.
You can still use it on with a system that does not understand the full ACL support, that just does standard Unix user and group permissions. But what happens is, if you've got additional ACLs on a file, that might say it allows the owner or allows the group but prevents Bob, who Bob might be in the group, but there's a specific ACL denying that. On the host that's accessing a machine that's exporting an NFS4 file system, that host, if it's only understanding plain old Unix user and group privileges, it might not see that that specific ACL denies Bob. When it tried to access the file, it would get a reject from the NFS server saying, no, I can't let you have that.
Wow.
Yeah.
Oh yeah, and then also the delegated administration. Here is a whole set of different properties for your ZFS file systems. In fact, there's more if I go up here. So I can set up a permission set to allow a user to, clone a file system, to create or destroy subfile systems. I can set up permissions to give a user the ability to, turn on and off compression, or change where their file system gets mounted by the mount point. And like, for example, I use that on, let's see here. Okay. Gotta look at the keyboard while I'm typing. Like here for my home directory, I've given myself permission to change and set all of these different attributes. So if I want to, create a snapshot of my home directory, just because with having snapshots, you can always reference a snapshot. If I, like here, each of these directories is a link into the snapshot of this user's home file system as of this date and time here. And so by giving myself permissions to set up those, change all these attributes, I can create my own sub-file systems. If I want to create a file system for doing some testing, changing with compression options or anything like that, turning on deduplication, I can make those changes myself and then destroy the file system when I'm done with it. I don't ever have to become root. This becomes useful especially with the Solaris zones, because then you can allow the users within a zone to manage their own local file systems without having to get the system global administrator involved. And then you've got the compression, that's been built into ZFS since the first release. And one of the more recent additions is the ability to have deduplication, which that comes in with the Sun's got their open storage systems now that they're selling, which those open storage systems are based on Open Solaris code, but it's not the actual Open Solaris distribution it's running. It's basically a trimmed down operating system with their own management interfaces on top of that. And so that takes care of that, it's got ZFS under the hood for all of your disks that you plug into this thing, whether you're plugging into big fiber channel arrays or plugging in, they've got like disk expander boxes where you can plug in, I think the biggest one you can take like 120 some disks, and then just build, big ZFS file systems on top of that, and then export it to NFS or CIFS for your Windows boxes, or iSCSI and other network services.
When you install Ubuntu or one of the other distros,
right,
you can always choose the type of file system that you want to use.
Okay.
Can you use multiple file systems under ZFS? I mean, is it?
Yeah. In that case, with Ubuntu, you're picking up how you're going to divide up your partition space between the Ubuntu, where it's going to install everything. I mean, with the Open Solaris distribution, you just installed everything on top of ZFS. It doesn't have an option like if you're familiar with the older Solaris, where it had its UFS file system,
Right.
You can't install on top of UFS anymore. Because actually the ZFS code, I remember back when they first released the ZFS code in 2005, when they first did the put back into the main Open Solaris repository, is that one of the folks who worked on it posted some stats, and that the old UFS file system code combined with the Solaris volume manager that did all your RAID and mirroring across your disks was like 30 or 50% larger than the ZFS code.
Okay, so ZFS is basic, I guess, this is, everybody understood this anyway, but I guess I'm just now catching up to it. That's basically your competitor to whatever the file systems that we would have in Ubuntu.
Right, yeah.
And we don't, they don't mix.
Right.
Okay.
Is Linux and stop putting ZFS into? into the Linux kernel?
We were actually just talking about that over pizza. Right now, there is a ZFS project that runs on top of Fuse. There isn't any work being done integrating the actual ZFS code into the Linux kernel. And there's a couple of reasons for that. One of which is the licensing, because with the GPL, it says that any code that you're incorporating into a GPL project also has to be licensed under the GPL. Another problem area is that the file system interfaces that the Linux kernel uses to its file system drivers are way different from what the Open Solaris interfaces that it uses for interfacing with its file system drivers. And also with the, there is some political in there. From the Linux side, there's actually originally one of the big sponsors of it has been Oracle for a new file system called ButterFS or BetterFS, which does a lot of the things like ZFS, where you have a pool of all your back-end storage, and then out of that pool you divide out into your file systems. It does compression. I believe they're working on deduplication for it. ButterFS was kind of done as a response to ZFS in some ways.
What was the outcome? I know there was a political thing. Didn't Apple half do it and then half not do it?
Well, it was weird because Apple came out with, like if you were an Apple developer partner, they've got that program where you pay like, I don't know, you pay like a yearly, that yearly fee, and then you get all their developer tools and everything. And from their developer site, they had a ZFS kernel module for macOS that you could download and install.
Right.
They didn't support it as like your boot file system. They only did it as like a secondary storage. And then they had that there, and there were rumors that that they were working on it. Then all of a sudden Apple pulled it back, and there hasn't been any word since then about why they changed their mind on that.
Yeah, I think it was a political thing.
There may have been. It's hard to tell because with Apple, a lot of their internal development is very internal. Just like with all the secrecy over any big Apple product release. You don't hear a whole lot about it until the actual day of. There's lots of rumors and everything, but it's hard to really substantiate as to exactly why they take some of the moves they do. Oh yeah, because I would have loved seeing ZFS on the Mac OS, especially because I remember there was like they had like a read-only version of the ZFS code. You could just read a ZFS file system on your Mac, and so there was like, oh, Apple's working with ZFS, and then like 2-3 months later they announced the Time Machine for Mac OS, and it looked like so perfect a fit with ZFS and snapshots that everyone thought, oh, that's how they're doing that.
Yeah.
But it turns out Time Machine actually just is doing like an rsync kind of process of copying data and making links and everything to keep the history. Right. And so it would have been nice to have ZFS, and who knows, maybe someday it'll suddenly pop out under something. I don't know. Oh yeah, and then the last thing is that the file system structure in ZFS, if they add new capabilities, like when they added the deduplication, all I had to do after booting into the next release that had the deduplication code in it is that I run a zpool upgrade, and it goes through and updates all the file system metadata structures to take care of whatever changes need to be done to accommodate. Like for deduplication, they added some new file system objects for keeping track of like the mapping a hash to the actual block. And so when you do the upgrade, it knows, oh, I'm upgrading from zpool version 20 to zpool version 22, and we'll go through and take care of all the changes for you while online. So you can do that to your root file system. The one downside is that make sure that you don't upgrade to like a new ZFS version and then have to reboot back to an old operating system that doesn't have that version of the pool support, because you wouldn't be able to boot off of your file system. You'd have to stick with whatever new release you had installed. Yeah.
Where are these pools running? Do they have to be running? Do they have to be peripherals of the machine that the ZFS is on, or can they be distributed over other computers? What's the
Well,
protocol?
it's not like a cluster file system where it's distributed between multiple boxes. You can create a ZFS pool out of non-local resources, something like a fiber channel connection over a fiber channel network to a big EMC storage box, or iSCSI connections to an iSCSI system that's offering up storage.
Well, what if, for example, what if you just had a Linux box running next to your Solaris?
Okay.
And you wanted to, I mean, with NFS, you could have done that.
Right.
So I assume you can include, have the pool of some part or all of the storage, the hard disks.
Well, in that case,
on a Linux machine, show up as
well, in that case,
pools
you
of
would have to
ZFS.
export the storage space from the Linux box as some sort of like an iSCSI, where the Linux is advertising basically a block device
Mhm.
that then an iSCSI initiator would, like my Open Solaris machine, would then talk to that iSCSI block device. And so it would still, on the Solaris side, whichever side was your initiator, it would still treat it like a block device that it's reading and writing from. There's a difference between a SAN, a storage area network, versus NAS, which is network attached storage. Something like a NAS is where you're having a file system, like NFS or CIFS. It just appears as a directory which has other objects in it, which could be other files, other directories, versus a SAN, where with a SAN you've got like your fiber channel or iSCSI, whichever machine is exporting those, they are like block devices that are connected over some sort of a fabric or network to your end node machines. And then the end node machines are accessing a block device, and they could put, you could have say a Windows inside a VMware VirtualBox connected to an iSCSI block device, and then on that actual block device you've got an NTFS file system. Or iSCSI to a Mac OS, you formatted it as a Mac HFS Plus. And so yeah, you would be able to, like in a Solaris machine, you could have a fiber channel card that's talking to your fiber channel storage, or dedicated Ethernet NICs talking to iSCSI backend storage. But most of the time, those are going to be a little slower performance compared to actual, directly plugged in disks, whether it's SCSI or serial ATA, SAS.
Can you convert like your VDV, your RAID things, can you convert from one to another?
No, not yet.
Okay.
That is one of the drawbacks.
Sometimes that comes into an issue, like things evolve and you say, well,
Right.
this just doesn't work anymore. I
Right.
gotta,
Well, you can do, there isn't a way to convert from, like, say, a mirror to a RAID. You can, next slide. You can, I've got coming up here, I've got some stuff
okay.
set up to demo some of the things you can do.
okay.
Because what you can do is, like, if you have a mirror, you can't take, 2 disks in a mirror and then add 2 disks and convert that to a RAID.
Okay.
But you can add your two new disks to your pool and expand your storage. You can also, which will be my next upgrade for this thing, is you can also do a replace of a device. Right now, my main storage in here is 3 500 gig drives, and my next step will be replacing those with like 1 or 1.5 terabyte drives, depending on what's economical at the time when I run out of space. And so what I can do is I can put the new drives in there, and basically one at a time do a replace on the fly while my system's running.
Okay.
And then what I do is I tell it I'm replacing disk 1 with disk 4, and it'll copy, resilver as they call it, all the data from the one to the other, and then at the end I can unplug the 500, do the next on second
Okay.
disk, third disk,
Okay.
and then at the end I've expanded the pool. It's still a 3-disk RAID pool, but now I've got 4 terabytes of storage instead of 1.5.
I've kind of done that with Linux, but it's kind of Interesting.
Yeah. One of the big things with ZFS is that they definitely wanted to guarantee the data protection. And so everything in ZFS has got checksums associated with it. All of your metadata, all of your user data. You do have an option for turning off the checksums for your user data, but the ZFS designers found out that, actually what's happened over the years is that, 20 years ago, you wouldn't want to checksum every single piece of data because that was going to be terribly, terribly slow. But over the years, your CPU speeds have gone up like this, and your disk I/O has gone up like this. And so actually now you've got enough CPU horsepower that doing a checksum on your blocks of data, is using such a small amount of speed. And now like some of the newer processors, like I think the new, was it the i5, the i7 from Intel has got some new improved math stuff that really crunches through doing like checksum operations on data. Every write to a disk is done in a batch transaction, and so whenever everything writes to a disk, it's guaranteed that the state on your disk remains consistent. There's no FS check in ZFS because a write either occurs to the disk or it doesn't occur. If something happened in the middle of a write, what happens is that basically you'd have that one write that would get lost, like if it happened in the middle of a write and your system panicked or lost power. Yeah.
What if your disks start to fail?
Well, if the disk starts to fail, what happens is the system, as it starts reading data, would start noticing those checksums aren't validating anymore.
Okay.
And if it's a simple bit error, then usually it can correct for that, and it'll flag the error. If it's a more complex error, if it's a complex error in your data, and you have actually that's my next slide here. Let's say here you've got a simple mirror, and we've got a bad block of data. So ZFS reads that, the checksum doesn't match, and it's like, okay, that's not right. Let me go read that from my other mirror, make sure that checksum is okay, and then once that's valid, we'll both pass that data to the application, and then also rewrite it back onto the other disk where the bad data was to begin with. Yeah.
You mentioned the speed of the processors and how that's
Right.
increased. Is that how RAID is done now in ZFS through the processor?
Oh yeah, it's all software.
Right.
Yep.
Right.
That was exactly my question.
Okay.
Because mirroring and RAID was all software RAID and not hardware RAID.
Right. But yeah, so all of your user data, you can turn off the options for checksumming, but then what happens is you don't know exactly if the stuff you're reading off disk is like what you wrote there 2 years ago. So it's good to leave that on. All of your file system metadata, like your directory structure, your permission bits, all of that is all checksummed. You can't turn that checksum off, and also they also keep multiple copies of that metadata too. Because if this bad block happened to be, instead of being your financial report from 2007, if it happened to be the user bin directory, that would be really bad if that got corrupted. So there's always, like in this case, if this was like a directory object, there would actually be 2 copies of this directory object on this disk and 2 copies on this disk as well. And that's because your file system metadata is going to be relatively small compared to the actual data contents that you're putting on there. And then also you do have an option. There's just a ZFS property. There's just a ZFS property that you can turn on to save multiple copies of your user data as well. And that's something that might be useful for like a laptop situation where you only have one hard drive. So what I could do is I could set that copies property to like 3. And then if I write a 10 meg file to my hard drive, it'll actually use 30 meg of space because it's going to write 3 copies of it to different areas of the disk. And then you can turn that on and off on the fly. Where, I can, well, I can do that right now. Do this. Actually, I gotta be root. No.
Probably password.
I might have forgot to give this user root privileges because I always had, because when I was working on all of this, I had multiple windows up with myself as root. So. And I can't type my password. Actually, I do have where's my, what do I call that one? What's that word? So like right here, I've got a just a file system I set up while I was trying a few experiments with VirtualBox. So right here on this particular file system, I've got 17 gig used. So we'll do ZFS set copies equals 3 on my cool VBox, and we'll make file 4 gig, 2 gig. Just. Now it'll sit there and that'll crunch away for a minute. But then after this is done now, when I do a DF, it'll show a total of 6 gig of space just got ate up by creating that file. And now one thing it does not do is that if you change a property like the copies or your compression or deduplication, it does not go through and like rewrite all of your old data to be under that new option that you set. It's just new data that would be changed. Like in this case, my VirtualBox image that I have here, that's not suddenly going to expand to take up 48 gigabytes because I changed this one property right now. Maybe I should have just done 1 gig.
I'm just curious, why do you do Control-Z? Is that how you end the command?
No, I was gonna kick it off into the background.
So technically, could you mount, like, if you made a block disk device in your ZFS pool,
Right?
like, I know with VirtualBox you can have it so it looks at, like, serial ATA connections. So could it technically find your ZFS pool locally using those resources instead of just a flat file in?
Yes and no.
Okay.
It wouldn't automatically find it.
No,
But you
you'd have
can-
to set it up
Yeah.
that way.
Yeah. In fact,
So instead of using like the VirtualBox, just flat file, you'd be using your kind of local file system to do
yeah. In fact,
kind of perfect.
these right here are all ZFS volume devices
Okay.
that I had created. And what happens is you get a
Yeah.
you basically get a dev node
Okay.
that exposes these different
Those.
ZFS block devices as a straight raw device.
Oh man.
And so then in my own in my user ID where I have VirtualBox set up,
Yeah,
then I
yeah.
just pointed at these raw block devices instead of pointing them at a flat file.
That's pretty cool.
And then also by doing that, what happens is you're not double caching by
Yeah.
by having both
Yeah,
by
that's
having this
exactly what I was
giant
thinking
file
about.
cached in your main memory.
Yeah. Then you can now call your hosting and your host machine or not.
Those involve disk.
Sorry to get off on a tangent.
Yeah, so there's a bunch of block devices. And then in fact, let's see what is the default. This phone name is for this ratio. So here I just use the ZFS list command to list out ZFS volumes and print the columns for name, used, available, and then the compressor ratio. So like you can see, for example, here I've got a Windows 7 virtual device, which is set up. Oh, what's the property? Yep. Oh, it does not involve block size. Oh, zip vault size. Yeah, so here my Windows 7 block device, I defined it as a 20 gig device. It's actually using 6 gig, and it's got a 1.5 compression on that. So in Windows, if I boot up my Windows 7 and I do a get info, it'll show I've got a 20 gig disk using about 9 gig of actual space. And so then all the compression and everything is being handled in the kernel rather than happening like up at the user land level inside VirtualBox.
Is this a function of VirtualBox?
No.
You allowing you to do this right now?
No.
No.
It's
Well, basically with VirtualBox,
Yeah.
you can just point VirtualBox at a disk device.
Okay.
And that's all I'm doing here. It's just that VirtualBox thinks it's given a raw disk instead of a file. So VirtualBox just thinks it's talking to a plain old raw, hard drive.
Okay.
But then all of the compression and the device links in my
the same way Oracle would with that block device, like you said earlier.
right.
The VirtualBox using it the same way.
Yeah, so I'm just pointing VirtualBox when in my configuration, instead of creating a fixed size or a dynamic size file to put my operating systems in, I just create one of these virtual ZFS block devices, point VirtualBox and tell it, go use that hard drive. And so, like for example, I could, I haven't done it yet just because the deduplication came out 2 weeks ago, and I just haven't had the time to start playing with it. But I could, for example, turn on deduplication, and then like if I copied a file between my Windows and my OpenSUSE VirtualBox, it would deduplicate that automatically. Let's see. Oh yeah, another useful feature with ZFS is the background scrubbing. Like in this case here, when you do a read of data, you're normally only going to read from, like in the mirror, you're only going to read one particular copy. Well, if you want to guarantee that everything is good in your file system, you do what they call a scrub. And that starts from the top of the top node, basically, of the Z pool, and walks down every single copy of every block in the file system in order to guarantee that all the checksums match all the way from the top to the bottom. So like in the situation there where I set those copies to 3 and then made a file, it would read every block of all 3 of those copies and validate the checksum on all of those. And I normally do that on my machine about once a month, set it up, let it run overnight sometime. You can also run it while you're actively on the machine, but I figure there's plenty of times when I'm not at home, let it go ahead and do work while I'm doing something else. Also, with the structure of having your different VDEVs, whether it's a RAID or a mirror, your writes get spread across all of your devices. And so that helps speed up things because as you're changing your disks, as you put in faster disks, it'll just automatically start spreading writes against those new disks. If it'll balance writes. So like if I've got my 3500s in there, if I added another set of 3 disks, it would see my 3500s now are really full, my 3 1 terabyte disks are empty. So now every time it does a write, it'll write like 3/4 to this disk and then just a little bit to this, until eventually they kind of come closer to being even. Since it knows these disks are going to be empty and they've got more space available, it's quicker to find free blocks on this disk as opposed to having to shuffle around and find holes wherever there might be remaining space on my old disks. It's got a smart prefetch algorithm. So in, for example, something that starts doing like a large, walking through an entire file, something like web serving where you're pushing out like a big file, it'll start prefetching that. If it's doing like a striding read, where it like reads a megabyte, moves 4, reads a megabyte, moves 4. Like I think it's after like 3 or 4 reads, it'll see that there's a pattern occurring and then just start prefetching, matching that stripe, so it's not sucking in an entire file into memory when you're only going to be reading 1/4 of it.
What is resilvering?
Resilvering is, that's what they call it when you are replicating data between devices. Like if, like in this case here, with the bad block, reduplicating the good data back over here, that's a resilvering action.
Oh, because of the mirror.
Right.
Okay.
Yeah, that's how they got the title.
Okay.
If like you unplug this device and then plug in a new one, and it has to replicate everything from disk A to disk B. But yeah, that's a
Recommitting
yeah.
it to
Yep.
a copy.
One of the, like in the past year or so, they've done a lot with ZFS with adding support for doing what they call a hybrid storage pool, where instead of just having, your main memory and then your disks, you can have SSDs kind of as an in-between layer.
Yeah, let's get it goofed now.
Yeah, well, and there's 2 ways that they make use of SSDs. There's read-optimized SSDs and write-optimized ones. So if you plug in some write-optimized SSDs, and you tell that to add that as a separate intent log, or a slog, then all of your synchronous writes, the writes that have to be committed to disk right now, will go to that write-optimized SSD. We can return, okay, your disk is committed to disk, or your data is committed to disk back to the application, and then later, over time, stream that data off of the SSD to the actual hard disk storage. Then the read-optimized side, you have a level 2 ARC. The ARC is the adaptive replacement cache, which that's basically your file system cache. On your normal file systems, you've got a file system mounted and the system sets aside space for your cache for files and metadata, all that in your main memory. With ZFS, since you've got a whole raft of file systems all coming out of, say, the same pool, they've got this adaptive replacement cache, because you can have data when you've got snapshots and clones of other file systems. You might have blocks on, data from separate file systems that are actually coming out of the same back-end blocks on disk. So the ARC is just an expanded cache that uses all your main memory. And then you can use an SSD as a level 2 ARC cache, where as you start reading data, it'll do like a slow write of like your most recently used data to this level 2 ARC. And then if you hit it again, it pulls it right from that read-optimized SSD instead of having to go back to your spinning disk and waiting for the disk to spin around. The level 2...
Let's go. I'm telling you
and the level 2 ARC is a big help when you've got a large data set that you're going to be accessing frequently that's bigger than your main memory, because your SSDs are going to be cheaper than throwing in 128 gig of RAM into a machine, and they're going to be faster but cheaper than cheaper than more memory but faster than throwing in more disks. One of the benefits with the level 2 ARC also helps with the deduplication, because if you've got a multi-terabyte storage pool, that table where it's keeping track of the hash of your block data to the actual backend, that table is going to get pretty big over time. And so basically that hash table of the deduplication table ends up mostly living in the level 2 ARC. And so when it needs to find a disk, it can go right to that SSD, pull it up right away, rather than having to find it across your pool of 48 disks.
Are you currently using any systems that have the SSDs? And
Not-
through this architecture?
Not yet, no.
Must have
If you look on the Sun blog site, there's one of the engineers by the name of Brendan Gregg. He's a big dtrace guy, and he also helped a lot with with their open storage products. And he's posted a number of screenshots of their management interface on the open storage of, like, here's all the IOs we're getting, all the disk IOs, and our response time, like for an NFS server, without the level 2 ARC. And now here's where I turn it on. You see like this giant scatter plot going along of disk reads all over the place, and then it goes like down to nothing. Because he had like it's 128 gigabyte memory in a machine, 500 and some, maybe 600 gigabytes of read optimized cache for the level 2 ARC, and then connected to like 16 or 24 terabytes of back-end storage. And with 20 nodes running some sort of a benchmarking program. And so then as he turned on the level 2 ARC on the SSD, within a short time, all of that data that was being accessed so frequently by all these different nodes got committed into the level 2 ARC, and now it's just pulling it straight from SSD instead of having to wait for disk. Which then helps your performance for everyone else who's then writing data, because now they're not waiting for the disk to finish coming around so you can get your read so they can get their write in. Then you'd asked about the Btrfs. I did kind of a comparison of between the two, some of the main differences. The license is a big thing. The checksum in Btrfs just has one checksum algorithm. ZFS, you've got a couple of different algorithms depending on how paranoid you want to be. If you're doing deduplication, then it automatically defaults to using SHA-256 instead of the simpler Fletcher algorithm. Btrfs, you can turn off the copy on write ability, whereas ZFS, it's always copy on write, so you're never modifying or touching any live data. One thing Btrfs does have going for it is that they do have device removal and defragmentation. That's one thing ZFS, folks who use ZFS have been clamoring for since it originally came out, was the ability to, like in my situation here, I've got 3 disks as a RAID for my main storage. There's no way for me to just say, I want to take 1 disk out of there and convert down to a 2-disk setup. I can always add additional disks later on, but like with 3 disks in a RAID, I can't convert to a 5-disk RAID. I'd have to convert to 6 disks in 2 separate VDEVs. And they are working on ZFS on what they call the block pointer rewrite, which would then give you the ability to remove a device, shuffle data around. The block pointer rewrite would also let you take, like when I was saying, if you turn on compression, it'll only compress your new writes to disk. The block pointer rewrite would then let you go back and re-evaluate, recalculate your old data under the new settings you have, and recompress or deduplication of your old data without having to manually do a copy of everything. Then one of the big things on ZFS is that you have the ability to do a snapshot of your file system and then use that snapshot to roll back to a previous date. dtrace, that's the system-wide tracing system for being able to debug and follow the execution of pretty much everything. Uses a really simplified language. It's similar to C, but not quite exactly. It doesn't let you do like straight looping, because they don't want you to be able to write a program that can just go off into the weeds and tie up all of your system. It has to be completely safe to run on any production system. And then there's zero probe effect when you're not actively running dtrace. So like right now on my machine here, if I list out the number of dtrace probes, there's a lot. Because it will, basically, you can put a trace on just about any function in the system at any layer. Whether it's in a kernel, whether it's in a userland application or a library. Okay, like right now, 68,000 some different probes in the system that I could, decide to instrument and follow their execution. And the picture on the window here shows it's got some safeties built in. If you do something silly, like in this case I told it to try and instrument every single probe in the system, it churns away for a couple of minutes and then comes back saying that it's aborting because there's no way it can track 195,000 simultaneous probes in from user land to kernel. With dtrace, you've got kind of a hierarchy. At the top, you've got your providers. Your providers publish a set of probes. Like there's a syscall provider for tracking your open, close, read, write. The PID provider lets you trace specific processes. The proc provider lets you dig through process information and execution. You can see when, set a probe for like seeing when a process goes on CPU or when it gets off the CPU. I/O for tracking your actual I/O through the system. And then FBT, that was the one that showed the most of the probes when I did the listing there. That basically lets you trace any function anywhere in the system. For your applications can also publish their own providers. In this instance here, when I took this screenshot, I had Firefox up and running, and one of the engineers added some probes to the JavaScript engine. So here are a bunch of probes for a create object start, and create object done from the libmozilla JavaScript library running in process ID 208.797.
Ivan, can you say again what is a provider?
A provider just publishes a bunch of probes that you can query. Let's see here, I've got some examples. Okay, here, what I'm doing, oops. If I would have edited my script. Okay, here, this is a real simple dtrace where I'm just tracing the entry to every syscall that occurs and then just counting up how many times that happens. So there's 237 syscall entry probes in the system, and right now what it's doing is it's counting all those, and as soon as I interrupt it, there it gives me, okay, there were 84 calls to open, 256 calls to write, 97,000 ioctal calls. The next one here, what it's doing is it's counting the syscalls and then printing out every 5 seconds which applications are doing the most syscalls. So my virtual box that I've got running over my other screen here, that's doing the most. Star Office, that's running a bunch. We've got some GNOME Terminal. And so this is looking, counting all those syscalls from every process and then just printing out the top, is it 10 here? Yeah, the top 10.
When would you use dtrace? What kind
Anytime
of
you're trying to
problems?
track down a problem. Because a lot of times what you do is you'll start with like a series of simple dtrace probes where you're just looking for some general things, and then you use that to find, see what you need to investigate next. Like in this case, if I saw some process that was suddenly cranking out 400,000 syscalls every 5 seconds, well then I'm going to want to construct a probe to probe this specific function or probe this specific process and see what syscalls is it's making that's running up this high count that's using up so much CPU time.
Those providers again, syscall was one of them.
Yeah.
There were
PID. PID.
And there were 3 or 4 others.
Proc, IO. Proc lets you trace the execution of a process. Like I could follow, which processes are coming on and off the CPU as the scheduler is making, decisions for scheduling resources. If I trace I/O, I can start seeing, when,
Right.
when a driver is, doing reads and writes to a device.
Okay, I can kind of see the pattern here of how these different providers would help you solve various problems
Right.
that are occurring.
Yeah.
Okay.
Well, like for example, this one here, if this shows because it's got the process ID at the end here. This is coming from a PID provider, and so I'd be able to do a probe on this process ID. Based off of this process ID, it would give me a number of modules. So since this is Firefox, I'd have like modules for the different libraries that were loaded in Firefox. Then each module has the functions that it's exporting probes for. And then, like for example, here, a lot of like the syscall probes. You have an entry call and a return call. And so what you can do is you can track the time that occurs between that entry and return and see how long it took for that syscall to execute. IPS is the big new packaging system. Anyone who's ever used older releases of Solaris, basically the old packaging system was, designed in the early '80s, and really, I think at some point, like one of the big innovations was they added the ability to, when you did like a package add command, instead of giving package add in just like a local file, you could give it an HTTP URL, and that was like a big thing. So IPS, IPS is one of the more contentious things because a lot of people have gotten so used to having the old packaging system.
Is it like the Debian packaging system?
Yeah, it's a fully networked packaging system. It's got all dependency tracking, which System 504 didn't have, which made life real difficult when you had a package and had to figure out, why is it complaining about this shared library that I don't have installed. You've got both a GUI and a CLI for managing everything. The multivariant packages means that you can publish a package which would have, say, both x86, Spark, and like architecture neutral data as part of that package. So instead of having to keep separate packages for a different Spark and an x86 package, you can just publish one package that has both sets of bits in it. Yeah.
Are these binary packages, or are they compiled locally?
Binary. Yeah, IPS does not have, it's not like a download and build system. You do all of the, the developer does all of the building and construction of the package. Yeah, and then commits that package to the package server. Here's our nice GUI interface for installing packages. Yeah, well, what they did was they did an evaluation of a lot of the other packaging systems that other systems use, and see, well, we kind of like this feature, and we like this, and we want to be able to do that, and kind of integrated it all together. One of the real handy things with IPS is that since it was designed to be used on Open Solaris with ZFS, is that you've got your boot environment, as they call it. And so in this case here, when I installed Open Solaris on this machine a couple of weeks ago, because I had been using the previous Solaris Express, which Solaris Express was just like the old Solaris release that just had newer updates. So it still had the old packaging system. It didn't have the it had like all the ZFS improvements, but it wasn't. It was more like the Solaris 10 releases.
Yeah.
And so I finally stopped officially putting out updates for Solaris Express to focus on just putting out Open Solaris as like the cutting edge of the source code. And so what I did one time was for my boot disks, I've got two 120 gig drives that I use for my boot drives, I've got set up with a mirrored ZFS pool. So I just took my mirror, disconnected one of the disks, because they didn't have a migration path, which is one of the sticking points that I kind of held off upgrading was because there wasn't an easy way just to do an upgrade from the old Solaris Express to Open Solaris. And so I finally, bit the bullet, getting ready for this year. I figured I might as well, actually install what what I'm preaching.
Do you use Tendo in production?
Hmm?
Do you use Tendo in production? Solaris.
I did back when we had our own hosting that myself and a couple of friends took care of here in Green Bay. We ran 10, but now actually we moved our hosting to an external hosting place that's running on Open Solaris.
Open.
But yeah, with these with the boot environments, when you want to do your updates, you just snapshot the root file system. It creates a new clone, installs your updates into that clone, and then you reboot right into it. So the total downtime is, the minute or two it takes to reboot. It's also handy, like in the past when I used to, when I had more free time and was keeping up, like instead of just installing the bi-weekly development releases, I was keeping up with the actual OS and networking updates, and compiling my own. Because you could just snapshot and clone your file system, install your own. I tweaked this kernel subsystem. Let's see how that works. I just snapshot and clone, install my patches into the clone, reboot, try it out. If anything breaks, I can just boot right back from my previous file system. It's still there. It's not touched because it shows up. Actually, if I go to here. So there's my, now I've got 3 file systems. So I've got my original install that I did a few weeks ago, an update I did like last week, and then one that I created just a couple days ago while experimenting around with things. For the desktop, it's GNOME. You've got Xorg. You actually have Compiz on the live CD. So if you've got like an NVIDIA or an Intel accelerated driver, you boot right up on the live CD right into a full Compiz enabled environment. Firefox Thunderbird. There's also a device driver utility that you can run, which that goes through, looks at all of your hardware, and then compares that against the listing of PCI IDs in order to make sure you've got the right drivers in the system for working on your hardware. Like this I just ran the other day on this machine. Everything I've got in here is all supported. Oh. Again, with the ZFS, they built an add-on for the Nautilus file manager that also works with a service that runs in the background for taking automated snapshots. So you just tick off that little checkbox there to turn on the time slider. And what you get is, like, for example, if I go in here where I was doing all my editing, and then I can turn on the time slider. And now here's, as of 10 o'clock this morning, go back farther, here's see what that 1 a.m. last night. I go back. Here's April 8th. So you see I did quite a bit of work there in the last week. And so what it's doing is just basically pulling up a view of all of those snapshots. In fact, you can even see, if I move the path here, you can see here, there's actually in my home directory, there's a hidden .zfs directory. Inside there, there's a snapshot directory, and then a subdirectory for each snapshot. And so all this does is it just pulls up that list of all of the snapshots that I have that exist.
Is it like rsync or is it ZFS?
No, it's ZFS.
ZFS does it?
Yeah. Well, ZFS does the snapshots. Where what happens when you take a snapshot is basically it keeps a copy, because everything's copy on write. And you've got your file system tree. When I write a new file, that file data gets written, then the directory that file is in, the metadata for that directory gets rewritten, then that cascades upwards to the top of the file system. So every write, there's all these changes that contain all the new block pointers. Since everything's copy on write, I write my new file. My old directory, a new copy is written, and then this old one is deallocated. Now that has a new block address, so its parent directory gets rewritten, and that has a new block address. With a snapshot, what happens is basically at the end of everything, all of your old without a snapshot, your old blocks get deallocated once that final write is committed. With a snapshot, you just keep a pointer to the block at the top of your file system. So you're actually not deleting those old blocks once they would have been usually freed. And so just by referencing the old tops of the file system, the old, what used to be the main directory, you can see all those different snapshots. And so ZFS has the snapshot ability built in, and then this is just a nice add-on for the Nautilus file browser for GNOME that gives you, the ability, because otherwise, like if I go to my terminal, I can do list, type all, what's my, cool, home, new log. Oh. List, all, new log. Oh, I know. Recursive. No? Oh, come on. Oh, you know what? I'm on the wrong machine. That's why. That was on my hosting provider. Oh. So here's all of the actual, snapshots that are associated with this particular ZFS file system. And so when I CD into that directory, and then go into the snapshot directory, each of these is a directory that I can just CD into, like a ZFS auto snapshot, weekly, 408.
So you can pull data off of those snapshots?
Yeah. Yeah, each snapshot is basically a read-only copy of the file system as of the date and time that
So let's
snapshot
say
was
if
taken.
something's got corrupted, you can take that read-only and change it back to where it's write it.
If something got corrupted and you didn't have any other redundancy that ZFS would have corrected for, then yeah, you would be able to go into this snapshot. Well, it would only work if the actual file had changed between then and now, because you're still pointing to, like for example, let's see if I do. Yeah, like see for example here.
Yeah, no, that's the biggest feature.
Here, for a couple of days, I had a core dump in my home directory. I think Firefox fell over and segfaulted. And so here, when I look on the March 18th at 6:14 a.m., it has this snapshot of this core file. There's only one actual file in the file system. So like if there's any corruption, it's not like this one would be corrupted and this one wouldn't. Because there's only, it still just has one reference. But you can see in all of these snapshot directories, only these two snapshots still have a reference to this core file.
You can actually recover those files.
Yeah, yeah, because it's a regular.
How do you, what about when you start running out of physical
When your disks start filling up, then you either need to start deleting snapshots or buy bigger disks.
You never have too much storage. Do you use this concept of snapshots in development? Like, say I took this direction on an application and then maybe that was a bad idea, I go back to this other level. Sort of like an SVN kind of thing?
You could. It really wouldn't work out best for that. You would be better off using SVN or Git or something like that in that for actually maintaining like a source code history. But
I was thinking this would be almost the same thing.
But well, I mean, I could use this for something like way back in the day. There was a problem with like Firefox version 1, where every now and then Firefox would fall over dead and it would nuke your bookmarks file. And so if I would have had ZFS and snapshots back in that day, I always could have gone to one of my old snapshots and just pulled a copy of it from there. And so, well, let's see, that was 319.
What sets the granularity of the snapshots?
Yeah, notice how there was a sliding granularity too. It was like really, like I don't know how many
Right.
seconds in between.
Well, actually,
Is there some sort of cron or something
Yeah.
running
yeah,
to do those?
yeah. In fact,
It's got to be something.
services.
I'm assuming it's basically hourly, monthly, weekly.
Yeah.
Couldn't it be a cron, go through and delete the oldest ones, run out of space?
Actually, it does have that capability. You can set it to like at 80 or 90%, whatever you want. That it'll go through and go, oh, your file system's getting full. You've got like. Well, let me get to this.
Effective days. So I had to do something like 100%, but today is actually.
Okay, so here there's these ZFS auto snapshot services. And those are set up to do frequent, which is every 15 minutes, hourly, daily, weekly, and monthly snapshots. And then there's just basically, right now it's just a cron job that runs every 15 minutes and goes, okay, it's midnight, we need to do a frequent, an hour, and a daily. It's Sunday, I need to do frequent, hour, daily, weekly. It's the first of the month, do a monthly snapshot. And so yeah, this just goes through and takes all these snapshots. Yeah, so here you can see I've got daily snapshots, the 19th, 20th, 24th, and then April 6th, 10, 11, 12. And what it does is if it takes a snapshot and then later on it sees that there's been no changes, it deletes that extra snapshot. So like, even though, like for example, the span from March 24th through April 6th, I was gone for a handful of days for Easter, visiting my folks. And so I wasn't logged in, the box was still up and running. It was taking a snapshot every day, but then the next day going, oh, the difference between yesterday's snapshot and today's snapshot, there is 0 data changed, so I'll just toss out yesterday's snapshot because I don't need to keep that.
Is that also why they check sum everything?
Well, that's part of it, because basically the way that when you do the writes and it has to cascade up the tree as it does the copy on write for every directory that changes and everything up to the top of your file system. Basically, with the snapshot, you just then, after committing a write, you just don't free those old blocks that you've now written new copies of. And so your snapshot is just a pointer to that old top of your file system. Okay. Yeah.
So you don't have to do any more backups.
Well, if like, while driving down today, if like I would have gotten in a car accident, and thrown the machine 65 miles an hour across the highway, ZFS wouldn't have helped me on that at all. So it's so good to have some sort of, it's always bad to say you never have to back up because there's going to be some sort of circumstance.
You always need an off-site backup.
Yeah. But yeah, basically I don't have to worry as much about doing like, every day to day having some sort of a backup. And then I can just do like, every week do a backup of my weekly snapshot to some sort of an external storage. And actually just this week on one of the Open Solaris lists, I saw one of the new cases come across for the next improvement of the snapshot service, where they're going to add the ability to specify a way to then, after taking a snapshot, to then replicate it, like either by a ZFS send to send it to an external device,
Okay, so then
or to do like some sort of like an rsync process or something to send it to an external host.
Right. I mean but it was just seeming kind of obvious here that we're getting into that realm of the backup, and so that's what you're saying
Right,
there is.
yeah, this is handy for your, for the kinds of things that you might just have your occasional oops, where oops, I deleted that picture, let me go back to last week's and pull that out of there. You know, it's not.
But
Yep.
you're saying this next rev or whatever is getting to the point where it can do it.
Yeah, the next big update that they're working
real
on
backups.
with updating the snapshot service will be to change it so that it has the ability to then send these snapshots
Right.
somewhere else, whether it's an external device or off to a totally different system. Yeah, that was what I just mentioned there with doing the backup, sending the snapshots over to some sort of external location. And then also being able to do a little finer grain tuning. Like right now, these snapshots, there's a property that you can set in service to tell it how many days do I want to keep for daily snapshots. It's like a default of like 30 days for the daily snapshot, 12 for the monthly snapshot, and then I think the yearly, I forget what it has on there. But yeah, then you'll keep so many hourly or yearly snapshots. And so one of the other improvements is being able to actually set, you know, like this user wants to keep 4 frequent, 15-minute snapshots, whereas this user wants to keep 96, which would be 15 minutes for a full 24-hour period. Crossbow is a big networking virtualization addition that they've been rolling into the Open Solaris code. Basically, you can define virtual network interfaces and switches. So you could have, like for a virtualized environment, like with your VirtualBox, creating shared networks where instead of using like VirtualBox's user-level networking, you're actually using an actual in-kernel virtual network card, and then sending data at the kernel level between your virtual machines. It's an improvement in speed because that way you're using all the kernel level for doing transmitting data between your virtual machines instead of sending it through user land, which is then creating network packets and then copying it, then uncreating a network packet.
And these switches, what are those?
You could create a virtual network between like multiple virtual machines or zones on a Solaris machine.
Oh, okay.
So I could have a zone, which is a lightweight virtualization at the system level. Share a virtual network with a VirtualBox instance, and then you can assign limitations and controls on those virtual networks and virtual network cards.
What, I understand virtual box, a
Yeah.
virtual machine.
Right.
What binds or what's zone, what's it containing? I don't understand zone exactly.
Okay, an Open Solaris zone is basically a way to create like virtual machine instances without having any hardware emulation. It's entirely an operating system way of doing it. You basically have one kernel. I don't know if you're familiar with change root or chroot. Okay. Basically, what you're doing is you're making a copy of your operating system that then runs inside of a restricted. They call it a zone, which the zone ID is like part of, it's like a part of the identifier of that process.
Okay.
And so all the processes in a zone, when you're in a zone, you do a PS, you only see the processes that are in the zone. You only see the storage that is allocated to that zone.
Okay. So you could parse out and run a specific process or a specific group of processes with its own write memory kind of thing, and just let those run aside from the
Right. Yeah, well, like for
let's see
example,
if we had something that's sort of really time critical, or you know what I mean, or
well, actually, zones they're really lightweight because you're not having to emulate any hardware.
okay.
So there is, I mean, in some of the measurements I've seen back when zones first came out in Solaris 10, it was like less than 1% overhead between running an application in a zone versus running it on, you know, what they call the global zone, which is your main system image.
Okay.
Mm-hmm.
So these don't all have to be Solaris zones, one could be a Windows and a Linux?
Well,
That's more virtual system.
Well, it wouldn't be Windows.
Well,
but
I mean, you can do a Linux zone.
yeah, there is support for running some Linux inside of a zone. With the Linux emulation, what it does is basically there's an interposer middle layer that takes care of translating the Linux, the things that the Linux side, the applications running on Linux do, to the Solaris kernel interface. Like some of the like some of your signals, you know, like it's pretty standardized that, you know, sig hup is signal number 1, sig kill is signal number 9. But between Solaris and Linux, not all of these signal numbers are exactly the same. So what this interposer layer does is if a process running in a Linux zone calls, you know, sends a signal, that interposer traps that system call and then sees, oh, you're sending, you know, whichever Linux signal, that actually, you know, whatever Linux signal number actually maps to this Solaris signal number, then passes that to the kernel. The kernel would send that, you know, send that over to the Linux process that needs to receive it, and then translate back again when it gets to the receiving process.
Is there any technical reason, as opposed to political or economic, for why you couldn't do a Windows zone and a Mac OS zone?
Because it, I think it is mostly technical. I don't think there's really so much political reasons.
It really just couldn't be done.
Right, yeah, very different architectures, especially like Windows is completely different. Windows, you would need to have some sort of a virtualization, because like there's so many things on Windows that expect to be running on an actual machine. Unless you're running like, even if you're running like inside a VirtualBox, you know, you install the VirtualBox drivers, which then what that does is, you know, to Windows it says, hey, I'm a video card driver, but then is actually, you know, doing the translation in order to display right on your, you know, whether it's X11 or whatever native display you've got.
So Solaris zones could not be thought of as a competitor for like VMware or Zen?
No.
Okay.
But VirtualBox is. And VirtualBox.
Yes.
Oh, yeah, sure.
Yeah.
And it, just the Z and ZFS, does that mean zone file system, or what
No.
the heck does it mean?
Well, originally they were going to call it the zettabyte file system, just because they're trying to think of the largest size imaginable. But it turns out that actually ZFS can store, I forget how many. It's this one, Wikipedia.
1,000 people.
Yeah, they've got it. Here, you can store 340 quadrillion zettabytes.
That sounds like a big number.
Yeah. Basically, you can
So
store
it's a
petazettabytes. Yeah, so basically you store 2 to the 128 bits, which I believe one of the engineers has said that's something like being able to store enough data to store every single atom that makes up Earth. Or more than that, I forget.
Wow.
That's good.
That's amazing.
Yeah, well, they figured, you know, because they had been running into problems with the old UFS file system of having problems, you know, they had to do a bunch of changes to UFS to get it to work with 1 terabyte file systems. And then, you know, pretty soon, especially in the larger enterprise environments where you've got big
You mean
storage.
Bill Gates wasn't right? You need more than 640K?
Yeah, and so they kept running into so many limitations with UFS. They're like, you know, it doesn't make sense to go to 64-bit because we already had 64-bit processors for, you know, half a dozen years.
Yeah.
So the next size doubling, just go 128, and that should do us for a few lifetimes. But yeah, with the crossbow, with all these virtualized network interfaces, you can limit like how much bandwidth you can have between your different virtual NICs. So you could have a like a web server instance, and then give it a bandwidth limit. You could then have an administrative interface. That one then would not have any bandwidth caps as long as you're coming from like your internal network IPs. Here we go with zones. With zones, you've got isolated copies of the operating system running all on top of one kernel. And in each zone, you can do all of your resource controls. For a zone, you can set how much memory, how many processes a zone can have, and then the zone administrator can set how many processes, services inside that zone can have. Let me get to. So like right now I've got a couple of zones installed on here.
There's nothing analogous to this in Linux, is there?
Not that I'm aware of. There may be, because I know there've been a number of different virtualization things for Linux over the time. So like right here I'm booting up, this is a zone that's booting up.
It's like a open source version of Jails.
FreeBSD jails?
Yeah.
Okay, yeah, it's kind of similar to that, yeah. Yeah, so right here I've got my own separate file systems. I've got my own ZFS file systems that I can even, create shared user 3. So I can manage my own ZFS file systems inside this zone. It's running your regular set of processes. You've got, init, cron. It's got services that are running just like in the global zone, except this is an isolated instance where, if the global administrator for the system put limitations on my zone, preventing me from using, say, more than 300 processes, then I would only be able to start so many processes in this zone, and it would not affect other users on other zones of the same box. I've experimented with this around in the past of like setting up like a mail server zone and then a MySQL zone. And then those appear as, from the network side, from anyone accessing on the network, they look like separate IPs. You could have separate user IDs, logins for each zone. In fact, the place where we host, over here, where I'm logged into our host, this is just a zone on a machine on a box. I think we're actually in one of the East Coast data centers somewhere. And so here we've got all of our web server stuff running. It's just running on our zone. We've got it's been a while since I've touched this command. Because normally whenever I'm running on my own box, I don't have to worry about setting up resource controls for myself. Oh, there we go. What's this? Okay, so like here are the resource controls for this particular process ID of my shell. And then now here for our zone, here we have set up where we can have a maximum of 4 gig of memory used. We can have, we've got a CPU cap that prevents any processes in our zone from chewing up more CPU and slowing down the box for everyone else. We're allocated a number of shares, which Solaris and Open Solaris have a what's called a fair share scheduler, where if you have, say a mail server and a database server, you can give them each 10 shares. And then what happens is while they're running, say there's a lot of mail coming in, the mail server needs more speed, and the database server is not busy. Then the mail server can kind of go over like a regular limitation. It could use up to a majority of the processor as long as the other guy is not using it. But if the database server cranks up, then the database server is guaranteed to get 10 shares, and the mail server is guaranteed to get 10 shares. So the system will then, balance everything out. Yeah, so that's good in the systems, in circumstances where you have a number of things running on a system, because then you can, it's not a hard cap. And so if something needs additional CPU for a period of time, it can go ahead and use all that CPU, but then once somebody else needs it, the hog will get scaled back and everyone else can get their fair share, as it's called.
And if you're defining or you're assigning different IP addresses to the zones,
Right.
You need a switch or a router then to be defined to get them to talk to each other.
Right. You can create a virtual switch between those zones.
Okay, but what if a switch isn't enough and you're going to have to use a router? Do they mean, when they say switch, a virtual switch, they mean also virtual router?
Well, no, the switch is just a virtual switch. But then if I needed a router, I could create another zone, give it an IP on the switch side, make it run as a router connected to a public IP address. Basically act as like a NAT gateway between the virtual switch, like with if I set up a couple of zones on my machine. Say, okay, right here where I'm plugged in, I only get one IP address over DHCP. I could have a handful of zones set up, connected via a virtual switch to another zone acting as a NAT router that then connects using my main, the DHCP address I get on my Ethernet to talk to the outside world.
So it's on virtual everything.
Yeah. Yeah, I mean,
Nice box.
virtualizing a database server behind a NAT, yeah, that's not really going to gain a whole lot because, you know, you're NATed and you can't access it from the outside world. But you could set it up as, like, I could basically assign a subnet which is routed to my machine, and then that subnet exists entirely as a virtual network between, like, my zones or my VirtualBox instances, or if I was running Zen, I could have my different Zen DOM-Us running on that virtual network, you know, assigned to the box, and then do everything with setting up the resource controls, and bandwidth limitation to control, because I could put put say Windows in a Zen instance, and then put a limitation on the bandwidth to prevent someone from nailing that Windows box doing a denial of service. Branded zones, that's the thing I was mentioning before with being able to do like a Linux instance inside of a zone.
That's kind of almost basically a whole bunch of parameters defined for you.
Right. Yeah,
And
basically.
that's why the name brand. Yeah, all right.
Yeah, and originally the branded zones, they started rolling out the branded zones as an idea for running Linux inside of a zone. But it kind of, I wouldn't exactly say fell by the wayside, but it's not as heavily developed now because since then, things like VirtualBox and VMware have really taken off. And so you can still run, Linux, the basic Linux zone supports 2.4 Linux kernel, and then there's an experimental 2.6 Linux kernel. But since then, Sun's really done a lot of work with kind of generalizing the brands framework so that you can take like a Solaris, some application you have running on like your old Solaris 8 or 9 machine and migrate that into a branded zone on top of a Solaris 10 or Open Solaris system. And so Sun's been looking at more of using the branded zones as a migration path.
Right.
Because if you've got some, giant, server, which in 1999 was a great machine, but now it's, 16 processors at 250 megahertz, that's not really going to get you a whole lot these days. And so you can migrate it onto a newer system, which would have, a lot better capabilities. You get the advantages of having it sit on top of ZFS, so you're getting all the behind-the-scenes compression and everything, even though your application still thinks it's running on a Solaris 8 machine.
So basically, you've got backward compatibility
Right.
by
Yeah, and
as simulating an old operating system for your applications, which is really what you want.
yeah, and then in fact, one of the newer brands is the S10 brand, which is basically anytime they've been making a change in Open Solaris, that where there's some sort of an API difference or something that's changed between Open Solaris and Solaris 10, then they adapt the S10 brand to do that emulation. So any Solaris 10 applications that are, because you're getting an application certified from a vendor, a lot of times when you have to have a vendor certified application, it's really hard to just take that and put it on a new machine, and then the vendor just says, oh yeah, go ahead and use it like that. So by having the brands, they can still maintain the API compatibility, and for the vendor side, they're, as far as they're concerned, it's still a Solaris 8 or 9 or 10 system.
I just had a thought.
Mm-hmm.
You know, like, there's this controversy about net neutrality.
Okay.
I was thinking this zone concept would be a very good way to implement that if you were, like, say, an IP provider, and you wanted to say, Google has to pay me X amount of dollars per year per whatever. Then you could say their processes will not run unless I tell them they can.
Well, I don't know if that would apply directly to zones so much. I mean, you could do stuff with the network virtualization of putting limitations on, bandwidth limitations, because you can control based on like the
I'm not thinking about
local
bandwidth,
IP or
more thinking about IP address.
yeah, well, because you can put set the controls based off of local IP or the remote IP.
Right, it would be very configurable.
Right.
So if they don't give us our money this week, then we're gone.
Turn the tap down. XVM, that's Open Solaris's implementation of Zen. It's again, since you're running it on top of Open Solaris, you've got ZFS. You can use the network virtualization, like I said, for doing the virtual network between your Zen instances. Support for both running Open Solaris as your DOM0, which is your root node in Zen, and then also as your guest DOM-use.
What guests can you have on the XVM?
XVM supports, well, what it does is it does para-virtualized or hardware virtualized, so you can run Windows as a guest inside Zen.
Do people do that?
Yeah.
Yeah. Okay.
Yeah, well, I think John does a bunch of that.
Yeah.
Not on Open Solaris, but
Oh,
Yeah.
is that a free thing, or is that a commercial product?
yeah, everything I've been going through all of
The
here
XVM.
is all stuff that's all free and open source.
Okay.
So how does XVM compare to Zen? And I know you're a fan of Zen.
It is Zen.
Yeah,
Oh.
it's basically, it's the same Zen hypervisor,
All right.
but then it's implementing the changes in the Open Solaris kernel for being both the host and the guest. And because it's not using the Zen source code, which is like Citrix owns that now, or whoever.
I think there's about 3 different companies that claim they own it. I think it's open source, really. The core
Yeah.
of it is open source.
The main core of it is open source, and so like the actual Zen hypervisor code itself comes right from the Zen folks, and then there's the changes for Open Solaris for running on top of that.
So XVM is not depending on zones.
Correct. Yeah, Zen XVM is straight up Zen virtualization.
Which is hardware virtualization.
Right.
Somebody
So you
explain
could have
that
like a
someday. I don't
6502
know.
chip running on Zen.
The hardware.
Technical.
Kind of.
Well, I mean, if you wanted to.
Yeah, because with Zen, what it does is when you have a machine that has to have hardware virtualization, it actually runs QEMU to do the actual low-level bits.
Oh, okay.
That QEMU is the basis of the Dynamips Dynagen, Cisco router
Okay,
emulated
right.
part. See, thing pops up all over the place.
Yep. Yeah, and then for the storage, they've got this thing called ComStar, which is the Common Multi-Protocol SCSI Target. Basically, you're building this on top of ZFS. Remember we were talking about with the difference between storage network versus network attached storage, where you're doing like your Samba or NFS versus an iSCSI. Well, what ComStar does is you basically take your back-end storage, which your best benefit is when you're running it on top of ZFS block devices, and then exporting that. Well, if you've ever dealt with any storage, you've got your storage box. It's got your fiber channel cards on the front and your disks in there, and then you're connecting your fiber channel to your actual operating machines. Well, with ComStar, you take an Open Solaris machine, drop some fiber channel cards into it, or some 10 gigabit network cards. You start up the ComStar services, set up your ZFS block devices, use those to create logical units, as they call them, that you then export over a port provider to your server nodes. So basically you've turned an Open Solaris machine into a storage system, where now you've got ZFS doing compression and deduplication, and then serving out block data to your Windows or Mac or Linux or Solaris boxes over iSCSI or Fiber Channel or whatever other storage protocols. And the ComStar is actually what the Sun open storage hardware is based off of, where you're taking your ZFS, Sun builds a nice GUI interface on top of it that's all browser based and builds a whole lot of other management tools and then sells it. But the actual core of the ComStar services you can install on your box, and you'll start exporting your volumes to your other machines if you want to roll your own service. And then the last one here,
Our friend,
huh?
our friend from Redmond.
Right, yep. And then the last one is that in Open Solaris, they've implemented their own CIF server. You can still install and run Samba,
Right.
but the CIF server actually runs in the kernel level, so you get better performance out of it. Also, it lets you take your Open Solaris storage box, and you can join your Windows NT domain. So your Windows NT users are authenticating through your domain controller to access your storage. And then with ZFS and the snapshots, the ZFS snapshots actually get presented over the network like the Windows has the shadow copy service. So here on my XP machine that normally sits next to this machine, I booted it up, mounted my user home directory, and then got the properties of this presentation file we're looking at. And here you see the snapshots from April 10th, 11th, and 12th. So yeah, there's like I said, I've been using Solaris and Open Solaris for 16 years now. And so, a lot of these things, especially pretty much everything I've gone through here today, has all been since 2005 that this has all been integrated into the system. And especially with the Open Solaris releases, they've been doing a lot of the newer stuff, a lot of this, like the CIF server and the ComStar. These are all newer additions that Sun's been really working away at, with getting into, supporting a wider variety of things you can do with a box besides just being a Unix machine running an application.
Well, right here, this Windows shadow copy and the CIF server.
Right.
I mean, what do they even have there? Obviously, the Windows storage.
Yeah, well, the Sun
Server.
open storage box that you can buy, from that you can export your block devices, you can export a CIF service or an NFS service for your other Unix machines. Basically, you can export just about any kind of storage, whether it's a file system to Windows, Mac, Linux, or whether it's block devices through iSCSI or Fiber Channel. And then everything that I've been going through here today is all available free from the package repository. Like when I was installing all of this, for grabbing like the zone stuff, I just clicked on the option, told it to install the zone packages, and there they were. A lot of them, like the ComStar, it's just another checkbox I would check off and say, okay, download this, and I'd have the commands for start setting up my block devices and exporting those to my other machines if I needed to.
I'm curious as to, when when Sun bought Cray.
Right.
I'm curious to see what technologies they brought over. Some of this stuff that you have here is some of the stuff with original Cray.
Actually, from the software side, I'm not sure that there's a whole lot in the actual stuff I presented tonight. What they really got when they bought the Cray was the Cray Small Business Division. Because I remember exactly when that happened.
Yeah, I was living in Chippewa Falls.
Oh, okay.
Yeah.
All right.
Guys are, instead of the Cray people with the suits and that, the Sun people are skateboarding down the hallways.
Yeah, what they really got out of that was Cray's Small Business Division got into building, like at the time, Sun's biggest machine was like a 4-processor SPARC server.
Right.
And meanwhile, Cray had started to build their small business machines using SPARC processors, but they were doing like 32 processors. And so Sun really got the hardware for being able to scale up with the big servers right around the mid-90s. And like the first was the Sun Enterprise 10,000, which was like 64 processors, that was around mid-90s. And that actual design was like what the Cray business division was working on before Sun bought them out.
Oh, I see.
But what they really got out of that with that high-end hardware was not just putting a lot of processors in the box, but doing things where like you could have a card which had 4 processors and a big chunk of memory in there. You had your system with your back plane with 16 slots. So you could have the machine booted up and running. You could take a card, drop it into the box, go to your root shell, configure up that card, turn the power onto that card, run like a boot check on it, bring that memory online, bring those processors online, and never reboot your system. And then later on, if, like when I said with the fault manager, it could take a processor offline or memory offline if it starts reporting errors. On those high-end SPARC servers, you could then go into the box that has your, a dead processor and configure down that card. The kernel would then take any memory that was on the memory of that card and migrate that off to other free memory elsewhere. And then finally, after you deconfigure that card, pull that card out and replace it with a new card, or just replace the processor on the card and put it back in. So that kind of massive system scalability, and then the ability to do the hot swapping of the hardware without ever having to reboot the operating system. That's what they got out of the Cray side. And they got that and were able to really crank up a line of machines right in time for the whole .com bubble, which is when Sun's stock really took off, when everyone in the world was buying Sun machines.
Because they were the top.
Well, because if you needed a machine with 16 32 processors that it was guaranteed to never fall over in the middle of the night, you bought a Sun machine. But then after the .com bubble blew out, and then other operating systems like Linux got better, the hardware on the x86 side got better to where you didn't have to deal with messy interrupts and jumpers and everything like you used to do in the old days. And so then that's where Sun's hardware side kind of fell off, and they really weren't able to keep, especially on the low end, they weren't able to keep competitive with your x86 stuff. I mean, there are still plenty of places where on the really high end, there's a definite need for a giant machine with 512 processors. But it's just, you're not going to find as many places buying that as you are going to find buying your, standard, white box PC kind of hardware.
Yeah, thanks. I'm just curious.
Yeah.
It's interesting that, with the processors and memory, you can scale up and down.
Mm-hmm.
But with ZFS, you can only scale up, but not down.
Well, that's just, yeah, that's mostly an implementation issue. They are working on getting it so you can, restructure a pool, but that just has to touch so many different areas, and they definitely want to get it right before they put it out there and people start using it. And so that's been a, I know it's been in a big demand ever since the beginning.
Is it because they just can't do it fast enough? Because if you're going to pull something out, you've got to copy everything from there over to something that's
I think it was
a resource that's going to be left.
I think it's mostly a people resources, in that there's not, there's not a lot of people in the world that you'd want writing code to rewrite an entire file system. Like I certainly want, while I've toyed around with doing a few modifications and things like that, I've never gotten into file system stuff just because that's, an issue that if you get something wrong, you can easily blow up, all of your data. Also, while there was a lot of demand for it, I don't think until like the last year, there really wasn't a lot of commercial demand for it. So, like for example, while I could definitely use a feature like that, a lot of corporations weren't necessarily banging on Sun's door saying, hey, when can we get this? Mm-hmm. And so Sun probably wasn't putting a whole lot of resources into that direction because, they saw other things like deduplication or encryption, which is another thing that's also being worked on ZFS that'll probably land in the source code sometime this year yet, as being more pressing before getting to do the rewrite of being able to change your file system structure.
One quick question.
Mm-hmm.
All of this work that's being done on Open Solaris, is it being done by Oracle now? Since Oracle purchased it?
Essentially, yeah. Well, I mean, there are plenty of community contributors, just like there were when it was before Sun got bought out.
Mm-hmm.
But yeah, essentially now all of the Sun employees are now basically trading in their Sun badge and getting an Oracle badge.
Mm-hmm.
And so like over the past couple of weeks, I've seen more and more as Sun people post on the list. Now their name when I'm going over the mailing list, I'll see it'll be so and so at oracle.com instead of sun.com now.
I've seen the same thing at MySQL.
Okay.
They have that now too.
Right. Yep. Yeah, and so that's been one thing that's kind of slowed down the next Open Solaris release, is that you've got 25,000 some Sun employees that are having to go through the whole process of reorganization and restructuring to now be under the various Oracle business divisions and branches.
Right, and the whole business philosophy is different.
Yeah, there's some of that too.
Yeah. Profit center.
Yeah.
Other technology center.
Well, thanks for coming, everyone.
Okay,
Presentation.
great.